Hello everybody, welcome to another lesson, and actually today is the final lesson of Basic Math 2. Today we are going to talk about order of operations with real numbers. Since now we've covered all four operations with real numbers, we can do the order of operations with them. So, quick review here. We have PEMDAS. Please excuse my dear Aunt Sally. Whenever you have an equation with multiple operations going on, first you're going to do any parentheses. You always look for the parentheses. Those will always come first. Next to that, once you're done with your parentheses, if you have any exponents in your equation, you're going to do your exponents. Once you've dealt with parentheses and exponents, you're going to look for any multiplication and division. Multiplication and division have the same priority as we proved back in Basic 1. They take the same priority, so if you see multiplication and division, you work from left to right. And then once you've done your multiplication and division, you do addition and subtraction. Those have the same priority, which I'm going to prove to you why today. Those work from left to right. So, I have an equation here. I have 7 divided by 7 times 3. It has been erroneously taught that multiplication must be done before division. They have the same priority, actually. You just do them from left to right. Well, why is that? Okay, well, remember, when you divide by a number, that's the same as multiplying by its inverse. That is the same as multiplying by its inverse when you divide by a number. So, this 7 divided by 7 times 3 can be rewritten as 7 times 1/7 times 3. You just change this into an all multiplication problem. So that's why division has the same priority as multiplication. Well, let's go ahead and solve this. 7 times 1/7, well, any number times its reciprocal is 1. So that'd be equal to 1 times 3, which, as we know, any number times 1 is itself. You would just get 3. That would be your answer. So that's a bit of a review from Basic Math 1 there, as far as multiplication and division having the same priority. Now let's prove that addition and subtraction have the same priority. Let's prove addition and subtraction got the same priority, okay? You have 7 minus 6 plus 5 minus 3. It has also been erroneously taught that you have to do the addition before the subtraction. That's not so. They have the same priority. Why is that? Because when you minus a number, you minus a positive number, that's the same as adding its negative. So 7 minus 6 is the same as 7 plus negative 6. Of course, we have plus 5. But that minus 3 is the same as plus negative 3. It's the same as adding the negative of that number. So now you've just turned this into an all addition problem, which, if you have a calculator, you're welcome to use it. You're welcome to do that. Or if you know how to do this in your head, that works too. But remember, subtraction and addition take the same priority because subtraction is the same as adding a negative. So 7 plus negative 6, that would be 1. We'll still have plus 5 plus negative 3, right? 1 plus 5, that's 6, plus negative 3, because we're working from left to right. 6 plus negative 3, well, that's just positive 3. So your answer would be positive 3. Alright, so we just proved that addition and subtraction have the same priority. Also, a couple quick things before we dive into our main equations today. Let's say I have negative 3 to the second power. So I have a negative number inside the parentheses, then I have a second power outside as the exponent. Well, remember, that is the same as taking negative 3 times negative 3, because any number to the second power is itself. You're multiplying it by itself twice. So a negative times a negative is a positive. So then you'll have 3 times 3, it'd be positive 9. We have storms in the area, so I apologize if the lights just flickered and stuff. Probably got that little flip out there. I'm sorry about that, guys. Now, I can also say, if we raise this to the fourth power, if you raise inside of the parentheses any negative number to an even power, if it's to the second power, the fourth, the sixth, the eighth, the 10th, so on, any even number, you're going to get a positive result. So a negative to the fourth, that's going to be positive. 3 to the fourth, that's 81. So you would get 81 for that. Now, let's say I did something different here, though. Let's say I didn't put this in parentheses. I just have negative 3 to the second power. I can tell you right now, it does not equal negative 3 to the second, negative 3 in parentheses to the second power. It is not the same thing. Okay? Let's say I'm going to prove why. Because that negative 3 to the second power, that is equal to the same thing as negative 1 times 3 times 3 to the second power. That's a negative 1 outside of that 3 squared. So the negative 1 just hangs around. You'll have negative 1, our order of operations dictates exponents first. You'll have negative 1 times 9. Well, that's just going to give you negative 9. So whenever you don't have any parentheses, you just have a negative number to a power, to the second power, to whatever power. It don't matter what power it is, whether it's positive, whether it's odd or even, you're going to get a negative result. Now let's say real quick I did negative 3 to the third power. I have the negative 3 inside the parentheses to the third power. That is the same as negative 3 times negative 3 times negative 3. Well, a negative times a negative is a positive times a negative, which is a negative. You end up getting a negative number. 3 times 3 is 9 times 3 is 27. So if you have a negative number inside parentheses raised to an odd power, such as 1, 3, 5, 7, 9, so on, you're going to get a negative answer. So that is a good rule to follow. That's a good rule to know. If it's inside parentheses, right, the negative number is inside parentheses, and it's raised to an even power, you're going to get a positive result. If it's inside parentheses and it's raised to an odd power, you'll get a negative result. And then of course, if you just simply put the negative number to whatever power, you're always going to get a negative answer. So those are some quick things to look out for. But let's get into why you're here today. We have our first real problem here. You have 8 minus 2 times 3 minus 9. Okay? That is our first real problem. Well, according to the order of operations, we need to do the multiplication first, because we don't have parentheses, we don't have exponents, but we do have multiplication. So, following the order of operations, you would have you have minus 2 times 3. Well, 2 times 3 is 6, so you have 8 minus 6 minus 9. Okay, so we've just figured out the multiplication. Now this is just a straight subtraction problem. All that's going to be. So 8 minus 6, well that's 2. You'd end up with 2 minus 9. Which, working with your calculator, or if you know this in your head, or if you remember the rules from the other day, 2 minus 9 would equal negative 7. So the answer we're looking for to that is negative 7. Right, so always your multiplication first, then you go through. In this case, all of it turned out to be subtraction, so that was pretty easy. Alright, what's the next one here? Alright, we have 2 to the fourth plus 2 to the third minus 10. Well, let's look at the order of operations. We don't got parentheses, right? Check that off. We don't have any parentheses, but we do have exponents, so those got to be solved first. 2 to the 4th power, that's going to be 16, plus, then you have 2 to the 3rd power, that's going to be 8, then minus 10. Okay, now we're simply reduced to a simple addition-subtraction problem. Remember, addition and subtraction have the same priority, so you're just going to work from left to right. Start with 16 plus 8, you'll get 24. That'll be minus 10. Well, 24 minus 10, that's going to be 14. So, the answer we're looking for is 14. So far, not so bad. Alright, what's the next one here? We got 4 times 5 minus 2 times 6 plus 4. Okay, so we have our equation again here. Let's look for parentheses first. Always look for those first. Do you have any? No. So next look for exponents. Do you have any exponents? You do not. We do, however, have multiplication in the fact that we have 4 times 5, which would be 20, because you're going to do your multiplication first, minus 2 times 6. That is also multiplication. That would be 12. Then you have the plus 4. So I have 4 times 5, which was 20, minus 2 times 6. Well, 2 times 6 is 12 because we do the multiplication first, plus that 4 on the end. Now you're left with a simple subtraction addition problem, right? So 20 minus 12, that's 8, plus 4. So we're left with a simple addition problem. 8 plus 4 is 12. The answer you would get for this would be positive 12. Alright. I got more problems. I have 6 more problems. I'm not just going to dump you here. Alright, this is a good one. We have 4 times 6 plus 8. That is, let's see. 6 times 4 plus 8 divided by 4 plus 3. Alright, so we have 4 times the quantity of 6 plus 8 divided by 4 plus 3. Well, what we got to do first, look for parentheses. We definitely got them. You're going to solve for what's inside your parentheses first. So you have 4 times, what is 6 plus 8? That is 14. We could actually do away the parentheses just to denote that we've solved them. So 6 plus 8 is 14. That'll be divided by, what's inside of the parentheses here, 4 plus 3. What would that be? That'd be 7. Okay. Now we're simply reduced to a normal multiplication and division problem. Well, multiplication and division, they take the same priority, you just work from left to right. So therefore, what is 4 times 14? 4 times 14, so let's see, 56. That would be 56 divided by 7. Now we're left with a simple addition problem. 56 divided by 7, that's just going to be 8. So your answer would be positive 8. Alright. Let's look at the next problem here. Oh yes, we have negative 4 squared plus 6. This is a good one. So we don't have parentheses. We do have exponents. So remember, whenever you have just a negative number squared or a negative number to any power without parentheses, you're going to get a negative answer. So negative 4 to the second power, that's going to be negative 16 plus 6. you're left with a simple addition problem now. Negative 16 plus 6, which when you add those together, you'll get negative 10. That would be your answer. You would get negative 10. Alright. How about, there's another one like it. We have negative 5 to the second power plus 7. Well, again, according to the order of operations, we're going to deal with our exponents first. We have no parentheses, so let's move to exponents. Remember, whenever you just take the negative number to any power without putting parentheses, it's always going to be a negative number. So you would get negative 5 to the second power, that's equal to negative 25 plus 7. So now you're just left with a simple addition problem. Negative 25 plus 7, well, that happens to be negative 18. So the answer we're looking for here is negative 18. I still have 3 more problems. What is the next one? Until. Oh, the next couple are similar, but yet they're very different. You have 8 minus 7 minus 9. So you have 8 minus, in parentheses, 7 minus 9. Of course, order of operations always tells us to look for parentheses first. In this case, we do have it. So we'd have 8 minus, now what is 7 minus 9 inside parentheses? That'd be negative 2. Well, now you have a positive minus a negative. Remembering from the other day, anytime you minus minus, it becomes plus. So 8 minus minus 2 is the same as 8 plus 2. 8 plus 2, well, that's 10. So the answer we're looking for here is positive 10. Remember, always do your parentheses first, and anytime you have a negative of a negative, that becomes positive. So that was if you arrange your parentheses one way. Now this is going to be a little bit different. It looks like the same problem. You'll have 8 minus 7 in parentheses minus 9. They look about the same, but they're very different. It's all in the placement of parentheses. Some people might say, what about the associative property? That works for straight addition. If this were a straight addition problem, you could then move the parentheses and get the same result, but this is a subtraction problem. You can't. So 8 minus 7, we deal with the parentheses first. That's going to be 1. You'll be left with 1 minus 9. So we have a subtraction problem. 1 minus 9, that equals negative 8. So the answer we're looking for there is negative 8. You see, we got different answers based on where we put the parentheses. So placement of parentheses is everything. I got one last problem here, and I think this is going to be a good one. Alright, here we go. We have 3 minus 5. That quantity to the second power minus, in parentheses, 7 minus 13 all over 12 minus 9 to the second power plus the quantity of 11 minus 14 to the second power. That looks hideous, I'm not going to lie. It looks really hideous. Well, first thing to do, you have parentheses. Let's work through what our parentheses would be. 3 minus 5, that's negative 2 to the second power. We'll deal with the exponents in a minute. Minus, what is 7 minus 13? That's negative 6. All over, what is 12 minus 9 inside that parentheses in the denominator? Well, that's 3 squared. That's 3 to the second power plus, was 11 minus 14 in the parentheses. That's negative 3. You'd have negative 3 to the second power So now we have it reduced down to -2, that quantity to the second power, minus 6. That's all your numerator, over for your denominator, 3 to the second power plus -3 to the second power. Well, order of operations dictates next that we do our exponents. So remember, whenever you have in parentheses any negative number raised to an even power, whether it's 2, 4, 6, or so on, you'll get a positive result. So that -2, that quantity of the second power, that's going to be +4 minus 6 over, what is 3 to the second power? Well, that's 9. Plus, now that -3 to the second power, since it's in parentheses, that'll give you +9. So far with me? So we've done our exponents. Now, I'm going to bring it over here. Next thing we're left with simple subtraction and addition. Let's start with the numerator. We have 4. Now minus makes a plus. That'd be 4 plus 6 over 9 plus 9. Right? Okay, now we have simple addition problems in the numerator and denominator. 4 plus 6, that's going to be 10. 9 plus 9, that's 18. It would look like we're done, but we need to simplify the fraction of 10/18. We're not done yet. Do they have any factors in common that will divide out? It turns out they have a common 2. 10/18, both numerator and denominator have a common 2. So we know 2 times 5 is equal to 10, and 2 times 9 is equal to 18, right? Well, the 2's will cancel out. You're left with 5/9. So the real answer to this would be 5/9. That'd be your final result. I feel like we should do one more like this. I feel like we should do one more. This was a loaded problem. That was a loaded problem. Let's do one more example. I know this was going to be it, but let's do one more. I'll feel better if we do. We might actually do 2 more. Let's say we have 20 times the quantity of 8 minus 3 minus 4 times the quantity of 10 minus 3. That's all in the numerator, over 10 times the quantity of 2 minus 6 minus 2 times the quantity of 5 plus 2. All of that in the denominator. Again, it looks like a very hideous problem, okay? First things, of course, order of operations dictates we do parentheses. So you'll be left with, in the numerator, 20 times what is 8 minus 3? That's 5. So you have 20 times 5 minus 4 times what is 10 minus 3? That's 7. Times 4 minus 7, all over. Now go to the denominator, do your parentheses. You'll have 10. Now what is 2 minus 6 in parentheses? That's -4. Minus 2 times what is 5 plus 2 in parentheses? Well, that's 7. Okay. We've dealt with our parentheses. We have no exponents, but we do have multiplication. So order of operations states we're going to do that next. Multiplication. 20 times 5, that's 100. Minus what is 4 times 7? That's 28. Over what is 10 times -4? That'd be -40. Minus 2 times 7, that'd be -14. All Alright, now we're left with simple subtraction problems in the numerator and denominator. What is 100 minus 28? That's going to be 72. So you'll have 72, then minus 40 minus 14 over negative 54. Well, first thing I would do, we know we're going to get a negative result because the number in the numerator is positive, the number in the denominator is negative. Go ahead, you can also move that negative sign into the numerator and get it out of the denominator. You'd have the same result. You'd have negative 72 over negative 54. Now, it would look like we're done, but it's not in its simplest form yet. We got to make this fraction into a simplest form. Do they have any factors in common that'll factor out? Yes, they have a 9. So on the side you'll have your negative. You'll have the 9. 9 times 8 is 72. Over, you'll have 9 times 6, that's 54. All of a sudden your 9's cancel out. You're left with negative 8 6. It would look like we're done, but we're still not. We're almost done. But do 8 and 6 have any factors that'll factor out? They do. They have a 2. That's going to be equal to the negative of 2 times 4, because 2 times 4 is 8, all over 2 times 3. Well, all of a sudden your 2's are canceling out. I'm going to write it over here. What you're left with is negative 4/3. You'll be left with negative 4/3 for your answer. Or if your teacher wanted it as a mixed number, it would be negative 1 1/3. Either way, you'd have the correct answer. I'm one of those that it's okay to leave it as an improper fraction, but some aren't. So just remember back when we were converting improper fractions into mixed numbers, how to do that. If you're unsure, I do have a lesson about that earlier on the Basic 1 playlist. I do have a lesson about that, so if you're unsure how to convert mixed numbers into improper fractions and improper fractions to mixed numbers, please see that video. It is very helpful. But yes, so that's what you'll get, negative 4/3. I got one final problem I want to do with you guys here. It's not quite as intense as these. In a way, it's not. But still a very good problem. Alright, how about we got, in the numerator, we got 5 to the 2nd power minus 4 to the 3rd power minus 3 all over 9 to the 2nd power minus 2 to the 2nd power minus 1 to the 5th. Alright, so in the numerator of this problem, we have 5 to the 2nd power minus 4 to the 3rd power minus 3. That's your numerator over a denominator of 9 to the 2nd power minus 2 to the 2nd power minus 1 to the 5th power. Well, we have no parentheses, but we do have exponents. We got to deal with those first then. So what is 5 to the 2nd power? That's 25. Minus, what is 4 to the 3rd power? 4 times 4 squared, that's 16 times 4, that's 64. So 4 to the 3rd power is 64. You'll just have that minus 3 hanging loose there. Over, let's do your denominator. 9 to the 2nd power, that's 81. Minus 2 to the 2nd power, well that's 4. Minus 1 to the 5th power. Well, we know 1 to any power, that's 1. So 1 to any power is 1. That's really easy. That's just multiplying 1 by itself 5 times, you'll get 1. Alright, so now it looks like in the numerator and denominator we're left with a simple subtraction problem. So 25 minus 64. Yes, I'm going to cheat. I'm going to use a calculator here. That would be negative 39. So you'll have negative 39 minus 3 over 81 minus 4. That's 77 minus 1. So negative 39 minus 3, that's going to be negative 42 over 77 minus 1. That's 76. Okay. Well, do we have any numbers in common that can factor out? Because I can tell you this is not in its simplest form, the negative 42 over 76. Let's start with 2. Let's start with 2 here. So you have negative times 2. 2 times 21 is 42 over what times 2 gives you 76? That's going to be 38, right? Well, your 2's are going to cancel out, so all you're going to be left with is negative 21 over 38. And 21 and 38 do not have any factors in common to factor out, so it's in its simplest form. The answer to this problem is negative 21/38. So really, just remembering your order of operations, please excuse my dear Aunt Sally, or if you remember that, you'll be able to do these. Remember, multiplication and division have the same priority. You work from left to right. Same as addition and subtraction. Those have the same priority. You just work from left to right. So that's really all there is to these. So with that, that concludes Basic Math 2. I want to thank everybody who has joined the channel so far, who has subscribed, who has been here and watched, who's given me like reactions, who's commented. You all are amazing. I couldn't do this without you. I just want to thank you all again, and I hope anyone else that's watching, please consider subscribing to the channel. It's absolutely free. It'll cost you nothing to do so. It's anonymous. If you're embarrassed to follow, that's understood. It's anonymous. It doesn't get shared with anyone. But I will see you all in the next video. The next video is going to be the pre-algebra welcome video. We're going to do that. So look for that here in the not too distant future. I hope everyone has a good day. Take care.